Is your existing supply chain and logistics consultancy provider failing to deliver? Our experienced, thought-leading team at Loguru could be your choice for an intelligent and friendly professional supply chain. If you have a challenge in supply chain, procurement, or logistics, or maybe just want to improve the value you get from them, visit loguru.co.uk. Complete end-to-end satisfaction guaranteed.
Coming up in this episode.
Average figures probably be about 20% more expensive to buy. However, the fuel is cheaper. So historically, the average, you're saving about 30% of your fuel cost for every mile that you're running a biomethane truck.
The Logistics Collective podcast is a series focusing on the sustainable future of the logistics industry. We'll discuss the industry's future challenges and interview thought leaders who can offer solutions. We're commencing our search for the higher level of intelligence needed to make the industry more sustainable and profitable. Here's your host, Malcolm Pope.
Welcome to the next edition of Logistics Collective, the podcast, and we're turning all sustainable and environmental in this episode. And I have a wonderful guest, Fjeld, who is CEO of Refuels. And what's Refuels all about? Well, clearly it sounds as though it's about finding alternative fuels to be able to drive our trucks. And we're going to explore a little bit in terms of the world of alternative fuels and why Philip perhaps will believe that his option is better than some of the others that are available on the market. Welcome, Philip. How are you today?
Thank you. Yeah, very good. The sun has returned outside. Feels like we've had 3 months of lack of rain, although we did have some on Monday. So no, all good, thank you. And thank you for having me on here.
Yeah, you're very welcome. What part of I'm guessing the wonderful world of the UK are you part of?
Currently, I'm in my home office, which is Beaconsfield, just west of London. But the company as such has an office in London, but our main presence is in the Northwest. We have our operations centred in Wigan in the Northwest.
Okay, Wigan I know well because I used to work for Heinz. That's just down the road from there. That could prove interesting in terms of as the conversation goes on, but we will see. This is perhaps all about digestion.
Potentially, yes.
Potentially so. So, look, Philip, obviously you've got a fantastic Scandinavian heritage because I had to learn how to say your surname, and I think I maybe got an 8 out of 10 for that. I'm scoring.
You did, absolutely.
Okay, not quite there. So, could you tell us a little bit more about what you do at Refuels? Well, what do you do personally and what do you do at Refuels?
Well, my Scandinavian background is very easy. English mum, Norwegian dad. Mum moved over to Norway, early 70s. I was born and brought up in Norway, bilingual, because my mum spoke English at home for decades, and then moved over here permanently to the UK in 2006. I've been in the gas industry since 2002, and in 2006 I came over here and founded a LNG, a liquefied natural gas shipping company, and so very much about global distribution of gas between continents. I left that in 2013 when the company got acquired by a new very large shareholder, and then established a company called CNG Fuels, which is the brand that we're best known by here in the UK. So what do we do? We develop, build, own and operate very large public access stations that dispense 100% sustainable and renewable fuel into large trucks, primarily the articulated truck market, so the HGV market. As I'm sure most of the people who'll be listening to this know that an HGV is technically anything above 3.5 tons, but our core market is really the articulated truck market, the 4x2s and 6x2s that do 100,000 miles each per annum. So we've currently got 16 large public access stations in operation across the UK. We've got more in development. Today we refuel about 2,050 Arctics daily through our network. About 10% of all 4x2 articulated trucks in the UK currently run on bio-CNG, as we call it, which is compressed biomethane. In the 6x2 market, the 44-ton market, our market penetration is pretty much close to 0% because the OEMs haven't been bringing out the 44-ton trucks before last year. So that market we're now starting to see move. And as such, we've got a lot of growth ahead. If you look at the overall articulated truck fleet in the UK, just to give you some stats very quickly, 145,000 registered vehicles on the road, there or thereabouts. About 1.3% of those currently run on biomethane exclusively through our network.
That's fantastic to hear. So thinking about this, we're on a transition. we're on a transition course in terms of net zero. So dirty old diesel has to go. And so there are a number of different options that you could take and you could consider. So there's an awful lot of focus in the industry, probably has been initially HVO. And HVO is a direct shoe-in product in terms of, okay, I've got pretty much the same truck, so I can use HVO to replace diesel directly without any real level of modification within there. But there might be some ethical considerations around HVO to take in terms of where are we actually getting the edible oils from there, and what impact does that have really from an acceptability criteria as well as sustainability and ethicality?
Correct. So if you look at HVO, first of all, it's a perfect drop-in fuel, because you can take your perfectly good existing diesel truck, you can run it with fossil diesel on a Monday, Tuesday, and a day or two after you can run 100% HVO. So as such, it's the perfect solution. The problem really comes down to, as you were highlighting here, what feedstock is being used to produce the HVO. Some of the people listening to this podcast, they might be aware that there has been historical controversy around palm oil being used to produce HVO. Then, of course, everyone said, well, it's going to be all of the waste-derived fatty acids from palm oil production. Now, the challenge there, of course, is that the two are chemically indistinguishable. So once it's produced, how do you know if it's come from virgin palm oil, which is causing deforestation, or if it's coming from a waste-derived product of already existing palm oil production? So the trend has been in the industry to move over towards used cooking oil.
Sorry, Philip, if I could stop you there.
Yeah.
Long time ago, I was an edible oils and fats chemist.
Okay.
So could I tell the difference between a palm oil fatty acid and palm oil actual? Yeah, just about. But your point is very, very well made. But the ethicality of it is the key point here, isn't it?
The ethicality, you're probably better than I am. I just know that if you look at the stuff coming out of Indonesia and Southeast Asia today, actually it's certified as a waste product because they are to some extent blended as well. It's really hard once it's been produced or once it's been processed if it's come from one or the other. But you're spot on. We really shouldn't be using virgin edible oils in biodiesel production because it causes land use change. So therefore, we should be using waste oils. And therefore, the focus has been to move over to used cooking oil and tallow, basically. The, of course, problem is that there's only so much used chip fat globally. There's only so much tallow that you can source globally. And therefore, if you look at HVO, the issue there is really, it's not necessarily about the end use of HVO, which I think we can all agree is great if it's done properly, and it's a brilliant drop-in fuel. It's more about the sustainability of where does the feedstock come from and in which quantity can you actually source it. And this is where, you can go down the rabbit hole a bit further, but it's highly relevant. As of the 1st of January this year, we had a sustainable aviation fuel mandate implemented here in the UK and in the EU. That has started out by a blending obligation of 2%, and that will then gradually increase to 10% in 2030 here in the UK. The challenge there, of course, is you need to produce it, and it just happens to be basically produced from the same feedstock that HVO is being produced from, which is used cooking oil and tallow. Yes, there are novel new pathways coming forward to produce SAF, as it's known as, sustainable aviation fuel, but they will need potentially decades to ramp up. In the meanwhile, you've got this fight on your hands between sustainable aviation fuel and HVO for road transport diesel, which are both going after the same feedstock types. And if you look at how these obligations are structured, it is likely that the sustainable aviation fuel or the aviation industry has a considerably higher willingness to pay. So therefore, they will be pulling in the feedstock into the aviation fuel sector and taking it out of road transport, which is a challenge for the scalability of HVO over time.
Absolutely accepted. And again, from that background, even used cooking oil or the waste products, the free fatty acids that you got either through chemical or physical refining of edible oils, they all had a use. They all had a use back then. So quite often they were processed into animal feeds. So if you're now no longer using them for animal feeds, exactly, and whether or not that's right or wrong is another question.
Yeah.
But it is, what are you now using to feed those same animals?
Correct.
And so there is a knock-on impact all the way through. So having sort of, I don't know, mildly critiqued HVO, the next one that is perhaps at the top of the list, and I think it was, we ran a little bit of a survey prior to this, whereby we were saying to people, what do you think is the most viable option? I think the top of the list was really electrification.
Yeah.
And there are some challenges with that for sure. What are your thoughts on it?
Yeah, I mean, you've hit the nail on the head there. It is at the top of most people's list. It's at the top of government's ambitions. I think the word here being ambitions. And in a perfect world, electrification is a great solution. All right, you have an electric drivetrain, which gives you a more efficient truck per se, but we all know there are some challenges currently. And where I'd probably like to draw most of the focus towards is there's a lot of focus being towards how the trucks are getting better. Our batteries over time are getting lighter, how there's extended range coming from the batteries. Currently, there is a payload loss if you go down the electrification route because the battery is so heavy, which of course means that you're making less money per load. Let's now make the assumption that over time, 5, 10, 15, 20 years, batteries will get better, that payload loss will go away, the range issue will go away, and so on and so forth. And everyone says, okay, job sorted, job done. No. How do you get your electrons into your vehicles to charge them so that they can carry out 300, 400, 500-mile work during the legal working hours of one driver? And that is really where we come fundamentally unstuck, not just here, but in most industrialized countries, or in most countries around the world, period. Why? Because we haven't got the capacity in the grid. So I'll give you one example. And we'll probably get into biomethane in a bit, but so we develop large public access infrastructure. We connect to the pipeline grid, so the existing natural gas pipeline grid here in the UK. We have compressors that start up and stop and draw gas off demand off the grid. We need a typical 1 megawatt connection in order to run a station that during a day, during a 24-hour period, can refuel between 600 to 800 trucks, okay? So we need a 1 megawatt connection, which in the world of electrification, in the world of electric trucks, is nothing. It's a drop in the ocean. 1 mega charger to charge one truck over a half an hour to an hour would need a 1 megawatt connection, okay? We are finding it increasingly difficult around the country to get a 1 megawatt connection. We've just gotten planning for a station in Swindon where we are looking to build a station. We need a 1 megawatt connection. We've been told that if we pay £972,000 now, we will get 1 megawatt of capacity in 2037. So with those type of timescales, and this isn't a one-off, we've got the same problems now across a number of our desired locations where we would like to build a station. Now, if you look at Swindon, it's probably got 500, 600, 700 trucks calling larger Swindon area home. If we can't get a 1 megawatt connection to run a gas station, how are you going to have enough capacity to supply 50 or 100 mega chargers, maybe more? So that is really where we have a huge problem with regards to electrifying, particularly the heavy end of the truck fleet. If you're looking at box vans, the 3.5 ton vans, 7 ton vans, etc., that go in and out of city centres, a lot of those can be electrified. All right, there is still a charging issue for some of the depots because they just can't get the capacity off the grid. But when you're moving up into the weight categories, it's really, really hard. And this isn't something that only the Department of Transport can legislate and say this is going to solve itself. This is hugely complicated. It's not just about the transmission network of national grid solving it. It's about all of the DNOs solving it. Then you get into NIMBYism. Then you get into the fact that local councils don't want stuff developed here, there, and everywhere. They don't want all their roads, chopped up for years to come because there needs to be new cabling, new substations. Someone needs to pay for this. We're into the hundreds and hundreds and hundreds of billions here. So it's a really complicated problem. And that's where I think, unfortunately, it's oversimplified by a lot of people only focusing on the trucks and saying, yeah, they're going to get better. You know what? They can be as good as they want. If you can't get the electrons into them, it makes no point.
And the view there is, okay, number of pieces I can echo within that. So there's one electric car in my family. You'll go around and looking at charging stations and you'll see a lot being built, but you'll generally see the charging machines present for a number of months before they're finally connected and they become useful. So that probably is part of the same cycle in terms of that. Yep, I agree absolutely from an infrastructure basis that there is a hell of a lot to consider. But even more than that is that we don't actually generate all of our electricity sustainably.
Right.
Yeah. So whilst we've got rid of coal and some aspects of debatable biomass, we still have a major amount of natural gas that we're actually using to generate electricity within there. So even though you're saying, well, okay, I've got a nice clean vehicle that's zero emissions in a city, the emissions are actually happening somewhere else as well. But, to some extent, to a greater or lesser extent, that might be the case for a number of these. So what we're saying is that it's going to take quite some time. And given that we are perhaps as a country not as good as infrastructure as we used to be, citing HS2 as an example, that perhaps this isn't the safe bet that a number of people that voted for it maybe think.
I absolutely, I'd echo that. And also want to make the point, we aren't anti-electrification. We're not anti, BEV trucks. As a founder of the company, as an entrepreneur, we are here to provide our customer base, which is an increasingly large percentage of the large fleets in the UK, with the energy vector, if I can use that term, that they desire or that they demand. If they came to us and said, listen, we've now got 10, 15, 20 of our big electric trucks. Can we please, charge them at your stations? Sure, we would bend over backwards to find a way to make that happen. But that's not happening. And these aren't small fleets. These are fleets that operate 1,000 trucks, 2,000, 3,000, 5,000 trucks. They have entire teams of fleet engineers, experts who obsess about what the next order is going to be of their trucks, who obsess about duty cycles, who obsess about pence per mile costs of running fleets and so on and so forth, just-in-time distributions, et cetera, et cetera. So we are, as such, we are a bit of a mirror here because we are reactive to what our customer base, which, as I say, is now 8 out of the 10 largest supermarket chains in the UK are now customers of ours. All of the parcel delivery companies are customers of ours. All of the large 3PLs are customers of ours. So we've got a very good finger on the pulse as to what they are demanding and what they are seeing as their solution for the next 5 to 10 years. And big electric trucks is not it.
It's interesting to hear. And I can understand why. I mean, without delving any further or too much further into this, our vehicles are more than forward motive or forward and reverse motive power to be able to move freight around. Quite often there is a need for other things, so power takeoffs, PTOs. You might need to have compressors, pumps. You might have to have some level of hydraulic pump to power on and offload cranes. And that then becomes a really interesting engineering view. But point to point, I mean, I've bought trucks over a number of years. I've not yet bought an electric truck, but I do go around and kick tires occasionally. And my amusement was, 4x2 new vehicle. I won't mention the manufacturer, at a weight of about 11.4 tons. When some of the lightweight vehicles that I was buying back in the day were less than 7 tons.
Yeah.
So that is an immense change. Now, some of that is on the basis of, you can argue more solid construction, crash resistance, all of that. But I would reckon most of that's battery.
Right.
It's interesting nobody's looked at battery exchange. We do it with MHE, but I'm not really seeing anything. Maybe I've missed it in terms of looking at battery exchange as far as this is concerned. So, having then looked at electrification and gone, well, yeah, we see the point of it in some circumstances, and we're beginning to get a stratified view of what might work. We then come to the wonderful world of hydrogen.
Yes, that is an interesting world. And, the word hopium comes to mind. And I think that sort of summarizes hydrogen a lot. Now, I've just turned 50, and clearly, I wasn't interested in hydrogen trucks when I was 10 years old. But, if you start digging around in the wonderful world of internet, you will find that hydrogen as a fuel, whether it's green or doesn't matter what color it has, as an energy vector to run cars and trucks has been talked about since probably almost before I was born. And it's always been the case that we only need scale. We only need a bit more development of the fuel cells. We only need, a bit more technology change with regards to and slight improvements on the electrolyzers. And all of a sudden, we are going to have economics that make sense. So here we are in 2025, we aren't there. So we've looked at hydrogen on a number of occasions. Why? Because we want to remain relevant. We want to make sure that we're not missing a trick. And again, we want to be able to react to what our customers want. We haven't got a single customer who's considering it seriously. The TCO with lots of total cost of ownership. So the TCO of running a hydrogen truck, and this is assuming the truck is free, right? For free. You are not paying for it because you're getting a government grant. The TCO of running it is 6 to 8x that of diesel. Now, let's be honest here. We are in a world where the average profit margin for a haulage operator is 3 to 5%, all right? Now, that's average. So there's some good years where it's higher and some bad years where they're losing money. They can't afford a TCO that's, 600% above where it should be. So where should hydrogen be used? Well, in my humble opinion, it should be used to decarbonize heavy industry. It's perfectly good for that. Go into refineries, go into petchems, petrochemicals, heavy industry. And it should be used for balancing the grid. It should be used for when we've got too much wind, we can't store electricity unless we spend trillions of pounds on batteries. So therefore, we need to find a way of storing electricity. And hydrogen is not a perfect way to do that, but it's probably the best way to store electricity. But as a fuel, as a propulsion fuel for vehicles, nothing has really changed in 40 to 50 years. And we aren't seeing anything on the horizon that's changing that.
It's really interesting. And I guess you also get with hydrogen the debate in terms of you have to validate whether or not it's been created from sustainable sources, because hydrogen most often is created from fossil fuels and industrial sources at this sort of point in time. I certainly see that sort of helping store energy across the grid. I think that's positive. I do think there's a question in terms of scale. So generally, when you're scaling up, costs will go down. I then begin to look at this sort of hybrid, or might be arguable mongrel solution. I mean, the argument there is that if it's difficult to build infrastructure, why not have a network of fuel cells whereby you can supply hydrogen into that and then generate electricity to charge your batteries? But I'm sort of thinking through that in a scientific way, and I'm thinking loss in terms of energy as you step through that. But nevertheless, it is interesting. I think Lord Bamford and his efforts as far as JCB and the use of hydrogen to fuel internal combustion engines was a different take in terms of this, and an interesting one. Who knows what is actually going to be successful. So coming to what might be the final option, and the option that you've backed, in truth, and that of biomethane.
Yeah.
I've got to declare to the listener, I had a fascinating conversation with Philip prior to this. He educated me in terms of why this might be the best option now and perhaps the best option for the next decade or two. So I'm going to ask Philip to explain why, because he was exceptionally persuasive when he spoke to me, and I'm no fool. So I'd like to understand from Philip, why is it biomethane? Why is that the thing?
So let's first start at a very high level here to explain what biomethane is. So it is 100% renewable and sustainable gas that is made primarily from waste feedstock. It can also be used made from crop feedstocks, maize, silage, etc. But when you're looking at road transport and the fuel going into road transport, it's all from a waste feedstock. So what do I mean by waste feedstock? That is food waste, sewage sludge from wastewater treatment plants. It's manure from farms, slurries from farms. It's agricultural waste and residues, waste straw, you name it. All right, and there's a lot of waste around. So anything that you could imagine could go on a compost pile and would over time biodegrade, become soil, and as part of that process, it emits methane. Okay.
So what you're saying is where there's muck, there's money.
There is.
But absolutely get that. We did a little bit of study on food waste, and shock horror is industry's got food waste pretty much, it's reduced a hell of a lot. It's under control. Less is going to landfill. But the amount of food waste going to landfill from domestic sources, the last time I looked, was about 6.5 million tonnes a year.
It's staggering.
And then you're then going to have a look at crop waste, which are, I don't know, the straw or the plant that's left over when you've taken the good bit away in the field that may or may not be ploughed into the field and just wasted. All of that has got a capability of being used to actually generate biomethane.
Correct. So this is then collected, put into a so-called AD plant, anaerobic digestion facility, which is basically a controlled, you've got tanks, you put waste feedstock in there, you stir it around a bit, and out comes the methane. The beauty here is also that is an incredibly versatile fuel, because once you've got it, you can clean it up, put it into the grid. You can create electricity on site. There are a lot of biogas facilities in the country that do that. It's a poor use of a incredibly valuable feedstock or raw biogas as such. I'd rather see we produce electricity from wind and solar and nuclear, etc. But once you've cleaned it up, you can use it to power trucks. You can use it to power, to heat homes. You can direct it to industrial heating applications. Once it goes into the gas pipeline grid, the market can essentially decide where it should go. All right. And if we have, let's say, biomethane is a transition fuel, which it probably is, but currently that transition is a lot longer than people think. It's not 10 years. We're talking multiple decades here. Let's assume there is a quantum leap in electrification of trucks 10, 20 years from now. You have all of this biomethane being produced. Does it need to be used in trucks anymore? No, you can then use it in other applications. You can use it to decarbonize industries that are really hard to decarbonize. Big factories, steel mills. Well, we haven't got any left now, but fair enough. You get the point. Any types of industries that are hard to decarbonize. So it's incredibly versatile fuel. It's cheap to produce compared to pretty much all of the other solutions that we've got out there. It has a lower cost of production than typically biodiesel does because of it's a local feedstock. It's a lot cheaper than hydrogen, and so on and so forth. And if you then look at the feedstock availability, you basically need a biodegradable feedstock. If I get my numbers right, we've got about 5 million tons of waste straw that is just left on fields to rot. Now, there's nothing wrong with it rotting because it goes back into the field. But once you've put it into an AD plant, you've extracted the gas, you get a wonderfully nutrient-dense fertilizer out of it that is called digestate, which is a much better way of fertilizing fields than just letting straw to rot. You've got the food waste that you mentioned, and the list goes on and on and on. The more industry starts to develop the biomethane sector, the more feedstocks it finds that previously, like poultry, litter manure, come off chicken farms, ammonia rich, go back 10 years, was a nightmare to produce biomethane from. Now, fairly simple technology solutions have come forward, which means that now all of that poultry and litter mix can be used for production. So what we're seeing across Europe is across Europe alone, there's about 30 billion euros that currently has been announced to expand biomethane production over the next 5 years. And based on discussions we're having with lots and lots of different funds looking to pour money into this sector, that's only the tip of the iceberg. So we're not worried about availability of feedstock. We're not worried about production capacity coming on stream. We're not worried about the longevity of this because us as humans, we create waste. We need to eat, we create waste. We need an agricultural sector that creates waste. So this is truly a solution that is a circular economy solution. And when you then go into trucks, you have the visibility of a long-term supply of biomethane. Getting back to the HVO discussion we had, and once again, I don't want to be seen as rubbishing HVO because it's an amazing drop-in solution. It's really a question of how certain can you be that one, the feedstock availability is going to be there, that two, you are going to have enough of this that goes into the road transport sector. And then more importantly, how do you know that the price is going to be right? Because if the aviation fuel sector can pay maybe twice as much as the road transport sector, all of a sudden you will find that your HVO that might have cost 20% more than regular diesel, all of a sudden is now costing maybe twice as much as regular diesel, right? Which is a big, big problem. And that's where biomethane comes in as a solution. We can do 10-year deals with producers, which gives our customers price certainty. So a lot to digest there. But at the end of the day, it's something that has great versatility. We know it offers very strong TCO, total cost of ownership, for our customers. And we've got the visibility that this is something that will be around for many decades to come.
So you're effectively saying, let's power the world with cow burps, which I think is a great idea. But on the other side of it is that there are further, perhaps less declared benefits to this. So if you have food waste, if you have agricultural waste that's going to either be left to rot in landfill or left on the fields, it will actually decay either aerobically, so that will introduce CO2 into the atmosphere, or anaerobically, which will mean it'll introduce methane. And methane is an order of magnitude more a greenhouse gas than CO2. So anything that contains methane is exceptionally useful. But looking at the costs of this, because we're seeing a lot of operators that are sweating in terms of the cost. If we said, looking at operating a truck using biomethane, which we might go and extend and say, is it truly carbon negative? Because you can grow crops out of the residue left over in terms of doing this. But what's the cost comparison if I'm operating a truck? The truck will be a little bit more expensive, but not that much more?
Correct. So let's assume that you're the fleet manager or fleet director of a haulage company or logistics company X. Let's assume you go out and you buy a diesel truck and you buy a CNG truck. And the CNG truck depends on specification, depends on your purchasing power, and lots of other aspects here, right? But average figures would probably be about 20% more expensive to buy, okay? So you are starting off with a slightly more expensive truck. However, the fuel is cheaper. So historically, the average fuel saving has been 30%. So pence per mile fuel saving. That doesn't include AdBlue, which you need for the diesel truck. So it's marginally higher, but let's use round numbers. You're saving about 30% of your fuel cost for every mile that you're running a biomethane truck.
Sorry, could you say that again, just so that you're saying in terms of fuel costs, 30% cheaper?
30% cheaper, pence per mile. So if you run your diesel truck 100 miles and you run your CNG truck 100 miles, your fuel cost of running that truck, both trucks 100 mile, on average is 30% cheaper for the CNG truck or for the truck that runs on biomethane. Okay? So you've got cost savings in there. So it's more expensive to buy, but the running costs are lower. What we've typically seen, and you have to remember, this isn't now a novel product that we don't have any market data, that we haven't got any customers that are using. We've got 176, I remember, 175 unique customers registered on our system. We've got north of 2,000 trucks currently going through our network every day. We've got operators who've been running dedicated CNG trucks now for 12 years. And some of them have operated trucks and have run trucks through their lifetime 1.6 million kilometers each. So this isn't a product that hasn't been tested. We know the economics are real. So what we typically see is the payback on your initial investment is between 1.5 to 2 years. So this is your initial extra investment. The average fleet operator will keep them for 5 years. Some keep them shorter, some keep them longer, but let's go average numbers. You keep them 5 years. So you've got 3 to 3.5 years of cash on cash savings of running your trucks. And as I say, these aren't speculative numbers. These are real numbers that we've seen from some of the largest leading fleet operators in the country. So it's a here and now solution that works, and that's why we're now seeing mass adoption.
So how are you scaling your business to deal with this?
So this country could do with north of 100 large public access stations. Now, when I say public access stations, what does that mean? That means a typical 1.5 acre plot of land that is close to distribution centers, close to major motorways, A roads, and so on and so forth, that can usually can refuel 10 to 14 trucks simultaneously, 600 to 800 trucks a day. However, we don't live in a huge country, but still, we are a lot of people on this island. We have a lot of, I would say, spread logistics needs in this country. It's not all centered around some of the main motorways and between the larger cities. You need to go deep into Wales, into Cornwall. You need to go to Inverness, into Northern Ireland. You name it, right? So we need a lot of these stations. What's challenging for us, though, is basically the common theme of developing infrastructure in this country. Negotiating with landowners can take a year, half a year to a year. Doing the surveys we need in order to submit planning approval can take us about 6 months to 12 months. Once we've got those 12 months done, we can submit into a planning application. That planning application can take us up to 2 years to have approved. There's nothing controversial about what we do. There's nothing in our station design. We don't have any ground pollution. We don't have any air pollution, no noise pollution. We don't build them in residential areas, et cetera, and then you go into building them and it takes 8 months. So for us, actually getting more gas into more trucks and letting our customers order more trucks is down to infrastructure. So we ourselves are holding back our own growth. So we are doing what we can to run as quickly as possible to get more stations built. We have a lot more coming, but unfortunately, we could do with some planning reform. We could do with lots of other reforms in this country, but we need to be realistic. And I doubt those reforms are coming anytime soon.
Well, that's one to note from a lobbying perspective, and perhaps a number of our logistics service providers, both regional and national, would be or should be open-minded to actually co-locating with these facilities. Because that would seem to make an awful lot of sense to me. Quite a number of these places do have waste that perhaps goes to landfill, and perhaps it could operate in a different way. So I want to sort of come to the last part of the interview, and it's been fascinating, Philip. Thank you so much for sharing time. But all organisations are as good as their teams. Could you tell us a little bit more about your team?
So we founded the company back in 2014. Myself and my co-founder, Baden Gary Smith. At that point in time, it was two of us. I've been a founder of businesses now since 2006. I think what probably annoys me the most when you read, the whether it's in the newspapers or someone's done a whatever it is, an article in a magazine or online, a lot of focus is put on the founders, the people that had the vision, came up with the idea. The reality is that's the easy part, right? The hard part is execution. Do
you think it's a problem with, very often if I'm talking about innovation to people, that they're so contained within how their world is constructed today, is that you've got to be incredibly persistent to try and get an idea forward.
Absolutely. And I also think not enough credit is given to the men and the women who don't necessarily have it in them to be the disruptors, to be the visionaries, to actually want to take on the risk of remortgaging your house, maybe putting your marriage on the line and having, years and years and years of stress. But what they do is they buy into the vision and they commit as much as salaried employees can do into basically jumping on board the ship and helping turn that vision into reality. And we've been incredibly fortunate to have attracted the best people I could ever imagine. I sometimes get asked the question, well, it's 11 years on now since we founded it in 2014, and people say, oh, that's a great job, Philip. You must be proud. Do you know what? Yeah, I am. But what I'm most proud of is our team and the people who work tirelessly and who get up get out of bed at 2:00 on a Sunday morning because we have an operational issue with one of our stations. That is dedication. That is execution. And as such, we've been incredibly fortunate to attract a fantastic team. And I'm pretty sure I could never recreate it, to be honest. There have been so many coincidences that just happened to fall in line. I could try to recreate it, and I'm sure I would fail probably 99 out of 100 times. So that is maybe just a bit of a comment maybe to people listening here. Don't focus too much on the figureheads and the visionaries, because at the end of the day, they are lost without all the others who make it happen.
It's very, very, very true. It's very, very true. But I'm still going to stick up for people that are visionary and do want to see a change, because in spite of that, you're absolutely right that you need to have team to support and team to deliver. But that spark of innovation is really important too. So a sign of a good interview is that we're running out of time for this one. And so the first thing I'm going to state is that I had a series of other questions I would have liked to ask Philip, but I was so excited about looking at biomethane as an option that I wanted to explore that, and I wanted to get a view, and it is a view. People can go and debate the objectivity if they wish, but I wanted a view on how does biomethane compare to where the other options are? And also, prior to this, it's saying, well, where does the industry think it's going? And the industry at the moment, from some of the leaders that responded to our quick little survey, believe it's all about hydrogen and electrification. But I would venture and advise very politely that perhaps they need to reflect a little bit more deeply. So what I would like to do is, I'd love to have another interview with Philip, so I'm going to see if he'll consent to that. But most of all, I'd like to thank him for his participation in this, and it's been enjoyable. Thank you.
Thank you so much for having me. And yes, I can tell you now, I'll absolutely join you for another one, because it's been mostly, it's been most enjoyable. So we'd love to continue.
Okay. There's all sorts of areas that my crazy mind can want to go and explore. So listener, thank you so much for giving me your time. If you are interested in what we do on the Logistics Collective, have a look at logisticscollective.com, and we're available on all of the podcast platforms such as Spotify, Apple, etc. And please like and follow us on there if you'd like to hear alerts about our future podcasts. We're well into our 4th year of podcasting, and it is a pleasant delight for me to do this. So thank you ever so much, and bye for now.
You can contact us by email at podcast@logisticscollective.com or by leaving a voice message on our website, logisticscollective.com. The podcast is a production by Leguru, who are part of Tompkins Ventures, a global collaboration of advisory, matchmaking and investment partners solving global logistics and supply chain challenges more quickly and cost-effectively than our competition.